Where is each function discontinuous, and what type of discontinuity is it? Let's start with G. If I want a discontinuity, what we first want to look for is where is the function undefined? So, for this first one, where is it undefined? Well, it's where the denominator equals 0. Okay, so let's find out where the denominator equals 0. We set the denominator equal to 0 and solve it. All right, minus the 10 over. I now have 4x equals negative 10. All right, I divide by 4. X equals negative 5 over 2. So that right there for sure is a discontinuity because there is no value there. You create an undefined. But the second part of the question says, what type is it? Is it removable or non-removable? Well, to do that, what we want to look for is factor cancel to see if I can cancel something out. Because if it's a whole versus an asymptote, that tells me the different type of discontinuity. So trying to understand it better. So let's rewrite this function by factoring and see if we can cancel anything. That's the key here. So I'm going to focus on G. So G of x is equal to, well, hopefully you see the top is a difference of squares. That'd be 2x minus 5, 2x plus 5. Hopefully you notice the difference of squares. And on the bottom, if I pull out a 2 GCF, aren't you left with 2x plus 5? Kind of did some factoring kind of quickly there. And if I cancel that out, I now have g of x is equal to 2x minus 5 over 2. Alrighty. So this function is the same as this function. This just has a Swiss cheese hole that's been filled in. Not a Swiss cheese, that's actually smaller than that. A pinhole, I should say. And is this pinhole this? Yes. So that means this, since I cut it out, is called a removable discontinuity. So this is a removable discontinuity because the piece that was canceled out is the piece that created that. Thus, it's a little pinhole I can fill in. So for this H, we have to find discontinuities and what type. So discontinuities are right there. So what minus 2 equals 0? That's an easy one, hopefully. That's x equals 2. So that is my discontinuity. Now I want to see is 2, what kind of error does it create? Well, let's see if we can do this cancellation thing. That tells me a lot of what type of discontinuity it is. So h of x, if I factor the top, is x minus 4, x plus 4. And the bottom is the x minus 2. Nothing cancels. So really, this is going to be an asymptote. So you cannot just go fill in at 2. So this is called a non-removable discontinuity. It's a non-removable discontinuity. I'm going to put dis, just to save some time writing. Alrighty, this last function f, well, the discontinuity is right here. So the discontinuity is what plus 2 equals 0. That would be x equals negative 2. So x equals negative 2 is the discontinuity. What type? Well, you might think, oh, I can cancel those, but that absolute value does weird stuff. So right off the bat, you can't go, I don't know if I can't cancel those. So what does this look like? How do I tell what type of discontinuity it is? It's such a unique thing. Well, you kind of have to visualize what's happening at that. You have to do the limit. Because for it to be removable, shouldn't the limit exist? Non-removable, the limit does not exist. So let's see what if the limit is. So let's check the limit from both sides. So here, to do the limit from both sides, we have to use numeric process with a table. It's really annoying. So I'm going to take the limit as x approaches negative 2 for f of x. Okay, and I'm going to do it from the negative side. And I'm also going to do the limit as x approaches 2 from the positive side of f of x. And if these are equal, won't it be removable? Aren't they approaching the same dot that you can fill in the hole? But if they approach different values, we know it's non-removable because it has no limit. So here we go. We're going to have to do these, and we're going to do it with a picture. So here comes that picture. I am going to make a table. All right, right here in the middle is -2, which is undefined. All right, we know that right away. It doesn't work. And what I'm going to do is I'm going to try to approach that from both sides. All right, so I'm going to squeeze in from both sides and see what happens. So what's a number? Are we okay? -2 here. Are you okay? That's -3, -4, maybe a -2.5. Are you okay? Those numbers approach -2. On the other side, wouldn't that be like a -1.5, -1, 0? Can you see I'm crunching from both sides? Now, I hope I don't have to use the decimal. Maybe I can see it without the decimal. Got it? But I kept it so I could kind of see what's happening from both sides. This right here is the left-sided limit. This right here is the right-sided limit. We're going to see what happens. And all we do is plug in numbers. So as I plug in numbers here, let's plug in -4. So the absolute value of -4 plus 2 over -4 plus 2, that gives me -2 becomes a 2 over -2, which is -1. So that is -1. Okay, let me try -3. So -3 plus 2 over -3 plus 2. So isn't that going to be +1 over -1, which is -1 again? Do you guys see a pattern? If you took the time to put the decimal in, you will also see it's -1. If you took the time to put them all in, and no matter what you put in, it always -1. Okay, all right, let's do the other side. So let's plug in 0. So if I do the absolute value of 0 plus 2 over 0 plus 2, isn't that 2 over 2, which is +1? If you do the absolute value of 1 plus 2 over 1 plus 2, you get 3 over 3, which is +1. And if you look at the pattern, you get +1. If you do a -1.5, you get the same. Oh, by the way, I screwed up. That's a -1, right? So let's fix that. If I do -1, wouldn't that be 1 over 1 anyways? Yeah. Oh, I even did 1. I did the one on the other side of here. I did that one over here for you now. But anyways. So can you see these are all 1 and these are all -1? Yeah. So what is it going to be at 2? Are they approaching the same value? No. This is, I'm approaching 2 separate values, so this is a question mark. It's question, I don't know what it is. So what that means is since they don't approach the same value, this discontinuity is a non-removable discontinuity. Again, because they do not approach the same side, meaning the limit does not exist